Assalamualaikum warahmatullahi wabarakatuh to Puan Mahani binti Muhammad Zamri. Today, my group want to present about the heat exchanger. In my group, I have three members. First is me, Muhammad Faiz bin Muhammad Yusof, and my battery card number is 01DPU1NF1021. And second is Muhammad Syami Izzaan bin Samsul Buhari. His battery card number is 01DPU1NF1006. And last one is Muhammad Nur Akmal bin Hisham. His battery card number is 01DPU1NF1025. Okay, we go to the next slide for the introduction of heat exchanger. And now we go to introduction of heat exchanger. A heat exchanger is a system used to transfer heat between two or more fluids. Look at the first point. Heat exchanger are used in the cooling and heating process. Point number 2. Liquid can be separated by solid wall to avoid mixing or maybe indirect contact. Then they are widely used in space heating, refrigeration, air conditioning, power plant, chemical plant, and petrochemical plant, oil mills, and more than that. A classic example of heat exchanger is found in an internal combustion engine, where the circulating fluid known as the engine coolant flow through the radiator coil, and air flow through the coil, which cool the coolant and heat the incoming air. Another example, look at the point number 3. Another example is a heat sink, which is a passive heat exchanger that transfer heat generated by electronic or mechanical device to a fluid medium, often air, and liquid coolant. That's all for the introduction of heat exchanger. And now, I will pass to Muhammad Nur Akmal bin Hisham to continue the slide about the type of heat exchanger.
Okay, thank you to Faiz for the instruction. Next, I'm Muhammad Nur Akmal bin Hisham from DPU 3A and my metric number is 01DPU19F1025. Okay, I would like to talk about types of heat exchanger. That's several types, such as first, we have plate exchanger, spiral exchanger, double pipe exchanger, air cooler exchanger, and shell and tube exchanger. Okay, next I would like to talk about double pipe exchanger. As you see in my slide is a diagram of double pipe exchanger. Okay, I want to tell you about double pipe exchanger. First, double pipe exchanger is simplest type, as one tube inside another, and in a tube may have longitudinal fins on the outside. However, most the number of tubes in the outer tube that can have very many tubes, thus becoming a shell and tube. Okay, next I want to talk about the shell and tube heat exchanger. As you see in the slide that show the diagram of shell and tube heat exchanger. Okay, I would like to tell you about the perjalanan there. First, the shell fluid in the right side, as you see in the slide, and then you throw the fin and you go the shell fluid out. It's the simple present from me from the shell and tube exchanger. Okay, shell and tube heat exchanger are the most important type of heat exchanger. It is used in almost every type of industry. This type of heat exchanger consists of a set of tubes in a container called a shell. The fluid flowing inside the tube is called the tube side fluid, and the fluid flowing on the outside of the tube is the shell side fluid. Okay, I want to tell you about the main component of shell and tube heat exchanger. First, must has bonnet, stationary tube sheet, support bracket, expansion joint, hot water out, stationary tube sheet, steam in, bonnet, tube bundle, spacers, and cold water in and steam out. Okay, there's several some common heat exchanger terms. Okay, first tube missile. Tube missile is usually you see the diagram before. He located at the inside the tube. Second, shell side. The shell side is located at the outside the tubes, between the tubes and the shell. And the third is tube sheet. Tube sheet a thick plate provided with hose in which the tube are fixed. Okay, fourth, the tube bundle. Tube bundle is consists of tube sheet and baffle plates. Okay, the last but not least, the common is a shell. Shell is a cylinder or plate in which in the tube bundle is placed. Okay, there's several shell and tube heat exchanger construction. First, he has fixed tube sheet type, U type, floating head type. As usual in my slide is first fixed type is the first picture is the fixed tube sheet. The second one is a U tube type, and the third one is floating head type. Okay, I want to tell about the front head type. There's two types, is type A and B type. Okay, first type A is channel and removable cover. Second is a bonnet, is a integral cover. Is the bonnet, you have the squirrel at the left side. And the third one is a E-type and F-shell. As a E-type, usually using like a pipe. It's a one shell, one pulse shell. And F-shell is a longitude baffle and a two pulse shell. Okay, I will continue the more shell types. Okay, G and H normally only used for horizontal turbine siphon boilers. J and H shell, if allowable pressure drop cannot be achieved in an E shell. Okay, if you want to between the G and H shell is you can show the split flow. If a G flow is the straight line, by the way, H shell is have a two split flow. You know from the slide you can show the double flow. Okay, J is same that split flow, but he did not have split flow. And X shell is a cross flow. Okay, I would like to continue with the low fin tubes. Okay, the low fin tube is flat and to go into the tube sheet, and it's available in a variety of metals including stainless steel, titanium and ingots. Okay, plate and frame. Plate and frame is a plate hung very vertically and clamped in a press or frame. Second, gasket directs the stream between alternate plates and preventing external leakage. Plates made of stainless steel or higher quality metal. If the plate made from stainless steel, it's more stronger and long lasting times. Okay, the lastly is a plate corrugate to give point of support and increase heat transfer. Okay, I would like to continue with the plate heat exchanger. If you see from the side, these are several components of the plate heat exchanger. First, support, column, inspection cover, roller assembly, movable cover, gasket, carrying bar, plate, pump, start bolt, fixed cover, frame foot, shroud, bearing board, titering buoy, lock lever, tightening nut and support foot. Okay, the plate type have two types. First, chevron. Second is washboard. Okay, the plate type is a corrugation of plate, improve heat transfer, give rigidity, many point of contact and terrestrial flow path. Okay, the last but not least for me, I want to tell about the general view of plate heat exchanger. You can show the diagram that I choose from the Google. Plate exchanger is a normally referred to a gasketed plate and frame exchanger. Okay, that's all from me, and I would like to continue with Faiz again. Thank you.
This slide show the flow arrangement within a PHE. Guess, look at the photos. This is a alternate plate, often same plate types inverted. The gasket arranged for each stream to flow between alternate plate. Now we go to the next slide. On this slide show the air cool or fin-fed exchanger. Look at the photo is for the example it. They show the hot flow in, fixed header, and hot flow out, height fin tube, tube support, sections, support channel, filling header, support, motor, speed reducer, fan, plenum, venturi. There's the processes and apa yang ada dalam air cool exchanger. We go to the next slide. Air cool exchanger is a blown across fin tube, 4-stroke type, and can suck air across into stroke. For more information, air cool heat exchanger are used to transfer heat from process fluid to ambient air. Process fluid is contained in a heat conduction tube. And then atmospheric air, which serve as a refrigerant, flow vertically across the tube to dissipate heat. In a heat exchanger cooled by ordinary air, the surrounding air is forced or driven by a fan or fans to flow vertically across the horizontal tube section. For condensation, packaging may be tilted or vertical. Similarly, for heat exchanger cooled with relatively small air, the airflow may be horizontal across a group of vertical tube. The ancient heat transfer characteristic of air cooled converter, the tube is equipped with extended fins. These fins can result in a significant increase the surface heat transfer. Parameters such as a bond length, width, and number of tube rows vary with specific application as well as the design of specific fin tube. The choice of whether an air conditioning converter should be used is basically an economical question including first cost or capital cost, operating and maintenance expenses, space requirement, and environmental concentration. The advantage of cooling with air can be seen by comparing air cooling with alternative cooling with water. This issue should be reviewed on the case-by-case basis to assess whether the air conditioning system is economical and practical for the intended application. The main component of an air-cooled heat exchanger include the fin tube bundles, fan and drive assembly, air planers place, and overall structure installation. And now, the last type of heat exchanger is spiral heat exchanger. Look at the diagram. The spiral heat exchanger have a tube side inlet, shell side outlet, shell side inlet, and tube side outlet. Spiral heat exchanger can be used in most applications in the chemical process industry. In more difficult applications where fouling and plugging are problems, a standard shell and tube design may not be effective. Point number 3. While a spiral heat exchanger often has a higher internal cost, it may provide a lower life cycle cost due to lower fouling rates and ease of maintenance. And then, a spiral heat exchanger is composed of two long, flat plates wrapped around the mandrel or center tube, creating two concentric spiral channels. the last point of spiral heat exchanger is, in a spiral heat exchanger, the hot fluid flow into the center of unit and spiral outward toward the outer plate, while at the same time the cold fluid enter the periphery and spiral inward, exiting at the center. In this slide, show the photo of spiral heat exchanger. Okay, that's all for the type of heat exchanger. Now, I will pass to Muhammad Syamil Izzaan for the example of calculation parallel flow and counter flow.
Thank you for Akmal and Faiz. For this slide, I will solve the question of parallel flow and counter flow heat exchanger. The question is, calculate the tube length necessary to perform the heat exchanger equipment below. First, I will solve the parallel flow heat exchanger, and then I will solve the counter flow. Okay, I done solve the question for parallel flow, and I will explain this. Okay, first we use formula L equals to Q dot divided by U times pi times diameter times delta T log mean. Okay, before we use this formula, we calculate heat. First, we calculate heat transfer rate for Q. Second is calculate convective heat transfer coefficient for U. Third is calculate our delta T log mean, and the last one is calculate length of heat exchanger. Okay, first one is calculate heat transfer rate for Q. Okay, this for formula for Q is m dot times C times delta T. M dot is for mass flow rate and C is for heat capacity. And now we go to the question. We choose oil or water to put in the formula. Okay, I will choose oil because it has m dot and it has C. So we can use oil to put in formula. Okay. M is 0.15 kilogram per second times the capacity is 2131 joule per kilogram degree Celsius times delta T is 100 degree minus 16 degree, and the answer we can get is 12,718 watt. So done for the question number 1. So the number 2 is calculate convective heat transfer coefficient for U. So the formula is 1 divided by H oil plus 1 divided by H water. So we go to the question and we can find the answer for H oil and H water. This is for H oil and this is for H water. So we put this information in the formula. So 1 divided by 38.8 watt meter square degree Celsius plus 1 divided by 2250 watt per meter square degree Celsius, and the answer is 38.1 watt per meter square degree Celsius. For number 3, we calculate our delta T log mean. So the formula for delta T log mean is delta T1 minus delta T2 divided by natural log delta T1 divide delta T2. Okay, first, before we use this formula, we must find delta T1 and delta T2. So, delta T1 is delta T1 equals to T in oil minus T in water. So 100 degrees Celsius minus 25 degrees Celsius, and we get answer 75 degrees Celsius. For delta T2 is T out oil minus T out water. So 16 degrees Celsius minus 15 degrees Celsius, and the answer is 10 degrees Celsius. Okay. Now we can put this answer in formula. So delta T log mean equals to 75 degrees Celsius minus 10 degrees Celsius divided by natural log 75 degrees Celsius divided by 10 degrees Celsius, and the answer is 32.2 degrees Celsius. Okay, the last one is calculate length of heat exchanger. Okay, formula for length is Q dot divided by U times pi times diameter times delta T log mean. So L equals to 12,786 watt divided by 38.1 watt meter square degree Celsius times pi times diameter. Diameter, we find diameter, this diameter 30 millimeter, we divide by 100 and we can get 0.03 meter. Okay, for times 32.2 degrees Celsius, and the answer is 110.6 meters. Okay, I done solve the question for counter flow. We use the same question, but the difference is at the delta T log mean. So we use formula L equals to Q dot divided by U times pi times diameter times delta T log mean. So formula for delta T log mean is delta T1 minus delta T2 divided by natural log of delta T1 divided by delta T2. So for delta T1 is T in oil minus T out water. So this is for delta T1. So 100 degrees Celsius minus 50 degrees Celsius, and the answer is 50 degrees Celsius. So delta T2 equals to T out oil minus T in water. So this is for delta T2. So 16 degrees Celsius minus 25 degrees Celsius, and the answer is 35 degrees Celsius. So we put this answer in formula. Delta T log mean equals to 50 degrees Celsius minus 35 degrees Celsius divided by natural log 50 degrees Celsius minus 35 degrees Celsius, and the answer is 42 degrees Celsius. So we use formula L equals to Q dot divided by U divided by U times pi times diameter times delta T log mean. So we get the answer for Q and U at parallel flow, and we put in counter flow. So Q is 12,786 watt divided by U 38.1 watt per meter square degrees Celsius times pi times diameter 0.03 meters and times delta T log mean is 42 degrees Celsius, and the answer is 84.8 meter. So for L parallel is the answer is 110.6 meters, and for the L counter is 84.8 meters. That's all. Thank you.